Okay, so this is the one formula you have to memorize. You will not find it in the data packet. You will find G is GM over R squared. Okay, you will not find E is KQ over R squared. Okay, memorize that, baby. Now, you could cheat, right? And you could write it inside the cover of your calculator, right? Or you could just look at the formula for G, right? There it is, right? It's the same thing, right? If you understand the parallels, you understand it's the same thing, right? So we've got a negative charge here, okay? If I'm above this charge, right? If I'm at a location above this charge, my electric field, the question is, what would a positive charge start to do? Right? If I put a positive charge here, it would start to go down because it would be attracted to the negative charge. And that's why my electric field is down. Okay. But here's what you can understand about this thing, right? Is that this electric field is in a direction away from Q. Okay. And so if we plug in the numbers here, it all works. Okay. By the way, there's an asymmetry here. Okay, because this one is toward M. Okay, so just understand that the data packet really should have a minus sign in front of this one and a plus sign in front of that one, because this is always an attractive force. Okay, gravity, masses always push the sheet of rubber down, whereas charges can push them up or down depending on the polarity of the charge. Okay, so anyway, let's take a look at this guy here, right? So our electric field is KQ over R squared, which is 8.9989 times negative 12 E minus 6 divided by 0.345 squared. So let's bust that baby out. Times negative 12 minus 6. Now, normally I just sort of ignore the minus sign here, but it's instructive in this case to not ignore it. And I get negative 906364.2 newtons per coulomb, right? So that is away, right? The default direction for electric field is that it's away. Because normally Q is like a positive charge and the electric field would be away. In this case, we get negative away, which means toward, right? Okay. Now, to be sure, I just don't do that. I don't use the minus sign here. I just always stuff a positive number in there and get a number. And then I look at the picture and I go, okay, look, if I'm above a negative charge, the electric field would be toward negative charges. And if it's above a positive charge, it would be away from the positive charge, right? So just remember that this electric field is toward negative charges, away from positive charges. Okay, and I'm always going to say above it or to the right of it or to the left of it, or sometimes I'll say look, and you can look at the examples, right? They're all like slightly different, but I'll say okay, there's I'm to the right of the charge, but there's an electric field to the left. Well, if I'm to the right of the charge and the electric field is to the left, it must be a negative charge, right? Did I get the right number? 1, 2, 3, 4, 5. I did. All right. So in this case, I would say away from negative away would be, in this case, down, right? Down. That much down? I don't know. All right. Good enough.